Okay, so let's talk about square root of negative number and complex numbers. Okay, complex numbers. So square root of negative number is not a real number. Okay, it's not a real number. So this is the definition of square root of a negative b, if b is positive. Okay, if b is positive. So we use a letter I stand for to handle this case. Okay, to handle this case. So for example, if you have square root of negative 2, okay, so by definition, what's square root of negative 2? Is I times square root of 2. Okay, so square root of negative 4 will be I times square root of 4, which is 2i. Okay, square root of 4 is 2, so this is 2i. Okay, this is 2i. So another equivalent way to see this letter I, or to see this square root of negative number, so we can define I squared is negative 1. Okay? Yeah. So I is an imaginary number. That's why we use letter I, imaginary number. Okay? I squared is negative 1, so what's the square root of negative 1? I. Okay? Yeah. So when you take square root of negative number, we look at these two parts separately. Square root of negative side, you get letter I. And then square root of the positive number, we use all the properties for real numbers. Okay, for real numbers. So now let's look at some calculations of square root of negative number. So if you have square root of 8 negative plus square root of negative 2. Okay, negative 2. So first we use letter I, so because we take square root of negative number and then radical 8, right? Plus I times radical 2. And then radical 8 is 2 radical 2. This is I 2 radical 2 plus I times radical 2. So now this is I times 2 radical 2 and the radical 2. We can combine them together. So this is 3 radical 2. Okay, 3 radical 2. And normally we write down 3i times radical 2. We change the order. Okay? Or you can write down this is 3 radical 2i. Okay? The order doesn't matter because this is multiplication. Okay, this is multiplication. Okay, yeah. So on the paper, I can accept all these three answers. Okay, they are the same. Okay, they are the same. So this is the addition. Subtraction is the same. Okay, subtraction is the same. So now let's look at a multiplication. Okay, a multiplication. So square root of negative 8 times square root of negative 2. Okay, so this is I times square root of 8 times positive 8. I times square root of positive 2. Right, positive 2. So now we have I squared square root of 8 times square root of 2, so square root of 16. So this is 4. So what is I squared? I squared by definition is negative 1. So we have negative 1 times 4. The answer is negative 4. Okay, the answer is negative 4. So you have to be very careful. Okay, you have to be very careful. So before this lecture, we have radical A times radical B is radical AB. This formula is true if and only if they are both real numbers. Okay, radical A and radical B are both real numbers. But our previous example, negative 8 square root of negative 8 times square root of negative 2, they are not real numbers. Okay, there's an imaginary letter I, so there's no real numbers. So this is not equal to radical negative 8 times negative 2. Why not? Let's calculate these two sides again, right? This is I radical 8. And that is I radical 2. So left hand side we get I squared radical 16. So this is negative 4. So what's the right hand side? Right hand side we have this is radical 16 positive 4. They're not equal. Okay, they're not equal. So this formula is not true because square root of negative numbers are not real numbers. okay, are not real numbers. So similarly, this is also not true. Okay, so these two formulas are true only for real numbers. Radical A, radical B has to be real, so that means A and B are not negative. Okay, A and B are not negative. So this is the multiplication case. Okay, multiplication case. So now we already know, so I squared is -1, right? -1. So what is +1? How can you get +1? We have two ways, right? We have two ways. So negative I squared, this will be +1. Okay, +1. Another way is if you square both sides, square this side, square that side, so you got I to the 4th power is +1. Okay, so there are some special properties of I. Okay, of I. So I to the 4th power is 1. So property 1, I to the 4nth power is 1. Okay, so here is n is positive because this is a multiple of 4. So this is I to the 4th power and then nth power. So this is 1 to the nth power is 1. Okay, is 1. So property 2. So we want -1, right? -1. So I to the 4n plus 2's power. So this will be -1 for any n. Okay, for any n. So this is I squared is -1. I to the 6 is -1. I to the 10 is -1. Okay, -1. Because each time we just add I to the 4th power, so which is number 1, right? So what's I to the 6? I to the 6 is I squared times I to the 4th. So this is -1 times 1 is number 1. Okay, is number 1. So what's I to the 10th? I to the 10th is I squared times I to the 4th times another I to the 4th. They are number 1. Doesn't count, so it's -1. Okay, -1. And similarly, we can get the other two results. 4n plus 1. So this is I. You have a lot of 1 and 1i, right? And then if this is 4n plus 3, this is -I. Okay? -I. So I is a very interesting imaginary number. Okay, imaginary number. So the most important thing is this definition. Okay? I squared is -1. So let's put it here again. That's the definition of I. Okay, that's the definition of I. Okay? Yeah. And we know how to add, subtract, multiply, and divide negative square root, right? Negative square root. So let's look at this division, right? So let's say we have 1 divided by radical -4. Okay, -4. So you have to be very careful, okay? It's not 1 divided by 2, or it's not 1 divided by -2, okay? -2. So you have to follow the definition. You change square root of -4 to I square root of 4. So this is 1 divided by I2, right? Radical 2 is 4, okay? So we have 1/2 and then I, okay? And I, what's 1 divided by I? Is -I, okay? It's -I. So this is 1/2. That's 1 divided by 2, and then times 1 divided by I. 1 divided by I is -I, so this is 1/2 times -I, so this is -1/2I. Okay, -1/2I. So it's very complicated, okay, very complicated. Okay, yeah. So for division, so my suggestion, you should also remember this property, right? So this definition is -1, so I squared is +1. So that implies 1 divided by I is -I. Okay? 1 divided by I is -I. Okay, so this is the square root of negative number part. Okay, square root of negative number part. So now let's go to the definition of complex numbers. Okay, yeah. So we already know I is square root of -1 or I squared is -1. So what is a complex number? Complex number is a plus bi. So here a and b are real numbers. Okay, a and b are real numbers. I is the imaginary unit. Okay, I is the imaginary number. Okay, imaginary number. It's not a real number. Okay, the whole thing a plus bi is called a complex number. Okay, a complex number. So for example, a and b can be 2, right? So we have, if a is 2, b is 2, then we have 2 plus 2i. Okay, if b is 0, okay, so if a is 2, b is 0, then we have 2 plus 0i. 0 times anything is still 0, right? So this is 2. If a is 0, b is 2, then we will have 0 plus 2i, so which is 2i. Okay, which is 2i. Okay, yeah, so a is called the real part. A is called the real part of complex number, and the bi is called the imaginary part of the complex number. Okay, of the complex number. So that's the definition of complex number. Okay, so now let's look at addition and subtraction of complex number. Okay, so this is a complex number. Real part is 5, so a is 5. So let's write down the definition of complex number. A plus bi, right? What's b? B is -2 for this number, right? For this number. And for the second number, a is 3 and b is 3. Okay, you have a real part, there's no I, and you have an imaginary part, there's an I inside there. Okay, inside there. Okay, so now there is a small typo here. So real part plus real part. Okay, combine like terms, right? Combine like terms. So we have 5 minus 2i plus 3 plus 3i. Okay, 3i. So they are the real part, 5 and 3. So we put real parts together. 5 plus 3. So you got the real number 8. Okay, you got real number 8. And then we put imaginary part together. Okay, imaginary part together. So we have -2i and 3i. So this is -2 plus 3. I is like a tail. Okay, yeah. So all you can see is just a letter. Okay, the meaning is I squared is -1. Okay, a letter with a special meaning. So -2 plus 3, we have 1. So this is a 1i. Okay, and sometimes we use just I stand for 1i. Okay, 1i. So this is the addition of complex numbers. Okay, real part plus real part, and imaginary part plus imaginary part. Okay, plus imaginary part. Okay, so now let's look at this subtraction example, right? Subtraction example. So we have 2 plus 6i minus 12 minus I. Okay, minus I. So real part is 2 here. This is 12. So the subtraction is for the real part and imaginary part separately. Okay, so the real part is 2 minus 12. Okay, and between them we put plus. Okay, so definition of complex number. So this is the real part plus imaginary part. Imaginary part. Okay, imaginary part. Okay, yeah, so this is the real part and the imaginary part. Okay, imaginary part. The imaginary part, so here is 6i, so we got a positive 6 here. Okay, and minus 1i, right? So minus 1i. I stand for imaginary part. Okay, imaginary part. So this subtraction sign is the subtraction sign between real parts and subtraction between imaginary parts. Okay, imaginary part. Okay, yeah. And then we got, minus -1, right? Here is -1. So it's minus, not 1, minus -1. Okay, so this is -1. So let's rewrite this as a complex number. A is 12, B is -1. So this is A is 2, B is 6. Okay, so it's A part minus A part, 2 minus 12. B part minus B part, so it's 6, sorry. So it's 6 minus -1, okay, minus -1. Then we got 2 minus 12, -10, plus 6 minus -1, so this is 7i, okay, 7i. So the result has also to be a complex number, okay, has also to be a complex number, okay, yeah. Let's look at one more subtraction because it's harder, right? It's harder. So let's say we have 2 minus I minus 3 minus 3i. Okay, minus 3i. So now in the beginning, you can always write down A and B for complex number, right? A is 2 here, B is -1. A is 3, B is -3. Okay, -3. So here is the definition of A plus BI, complex number. Okay, complex number. So this subtraction means real part minus real part, right? Plus I part minus I part, imaginary part minus imaginary part. Okay, so the real part A minus A, so this is 2 minus 3. Okay, and then the imaginary part, we have this B, -1, minus another B, -3. And then the imaginary part has letter I. Okay, has letter I. So this is the idea of addition and subtraction of complex numbers. Real plus or minus real part, A part plus minus plus B part, A part, B part plus B part, A part minus A part, B part minus B part. Okay. So now let's continue. We got 2 minus 3, -1 plus -1 minus -3. So turn to plus 3, so it's 2i. Okay, it's 2i. So let's look at one more addition, right? Let's look at one more addition. So it's 3 plus 3i plus -2 plus minus 5i. Okay, minus 5i. So again, here A is 3, B is 3, A is -2, B is -5. Okay, so this addition in the middle means A plus A part, B plus B part, and B part has I. Okay, B part has I. So let's write down the structure. Okay, so this plus sign means you have the A part here plus the A part there. So this is 3 and -2. Okay, and then we have B part here plus the B part. So this is 3 and -5. Okay, so the answer here is 1 plus -2i. The answer also has two parts. Okay, real part and the imaginary part. Okay, real part and imaginary part. So this is addition subtraction. Okay, so now so this is an easy multiplication example. Okay, easy multiplication example. So we have 7i times, so this is a complex number, times another one, 2 minus 9i. Okay, so each complex number has two parts. Okay, two parts. We just follow the distribution rule. Okay, distribution rule. So what's the A and B for these two numbers? So here A is 0, B is 7. You only have the imaginary part, right? Here A is 2, B is -9. Okay, B is -9. Complex number A plus BI. Okay, yeah. So distribution, 7i times 2. So this is 14i, right? 7i times -9i. So this is -63i squared. So what is I squared? -1. So we have to simplify that again. So this is 63 plus 14i. Okay, so this -63 and -1, they become a new positive real part, positive 63. Okay, 63. So essentially, it's just distribution. Okay, distribution. So our next example you can see is FOIL. Okay, so you have this complex number. A is 5, B is 4, times the other one. A is 6, B is -7. Okay, so the product of two complex numbers, two terms times two terms, FOIL, right? So this is F, 5 times 6, first times first, right? And here is the O, 5 times negative 7i. And this is the inner product, 4i times 6. And the last one is 4i times 7i. Okay, so FOIL. Okay, complex number times complex number is FOIL. Okay, is FOIL. And then we multiply that, 5 times 6, 30. This is negative 35i. This is positive 24i. They are imaginary parts, okay, the middle two. The last one, 4 times negative 7, negative 28. And then we have I times I, which is I squared. So each time, if there is an I squared, what do you have to do? You have to change I squared to negative 1, okay, to negative 1. So this is negative 28 times negative 1, this part. And then you got a new real part, 28. Okay, 28. Okay, so now real plus real, you got 58. Imaginary part, okay, negative 35 plus 24, negative 11. So imaginary part, the answer in the product is negative 11. Okay, 11. So the comment is, if there is an I squared in multiplication, change it to negative 1. Okay, negative 1. So let's look at another one. Okay, so before we talk about division of complex numbers, we have to look at FOIL again for this special conjugate complex number. So last time we talked about conjugate radicals, right? Just change radical A plus radical B, change to radical A minus radical B, you got conjugate. Here we do the same thing. If you have A plus BI, what's its conjugate? A minus BI. You just change the middle sign, okay? You just change the middle sign. And then the good property for this multiplication, okay? A complex number times its conjugate. What do you get? You get a real number, okay? You get the real number. Again, you cannot guess, okay? You have to use FOIL method. FOIL. All right, this is FOIL. Okay, so now let's look at the middle two terms. The middle two terms is negative ABI and positive ABI. So they canceled. Okay, they canceled. The first term is A squared. The last term, this term, you have B squared and the negative I squared. So what should we do about negative I squared? So I squared will become negative 1. Okay, negative 1. So negative b squared times negative 1, you got a positive b squared. Okay, a positive b squared. So now let's compare conjugate radical and the conjugate complex number. I will write down the result. Okay, write down the result. So if you have square root of a plus square root of b times square root of a minus square root of b, what do you will get? A minus b. If there's this conjugate complex number, this will be a squared plus b squared. Okay, b squared. So if you try to remember these two formulas, it's too hard. Okay, sometimes you got the wrong sign, sometimes you got second power, or forgot the radical sign. Okay, the radical sign. So my suggestion, you just use FOIL method and do it by yourself. Okay, the only thing you need to remember is if you have a bad radical in the denominator, you can use conjugate to change it to a good rational denominator. If you have a complex number in the denominator, you can use conjugate to change it to a real denominator, a better, good denominator. Okay, so we use these two formulas to take care of the bad denominators. Okay, bad denominators. So later I will compare them again. Okay, compare them again. But my suggestion is, don't remember, just remember that, just use FOIL. Okay, it's an easy FOIL method. Okay, so let's look at the division of complex numbers. Okay, so this is the division. Okay, this is the division. Numerator is 5 plus 4i. Denominator is 4 minus I. Okay, 4 minus I. Denominator is a complex number. So our job is change denominator to a real number and then rewrite this as a complex number which has real part and imaginary part. Okay, imaginary part. Okay, so now the idea is we use its conjugate. Denominator is 4 minus I, so we use 4 plus I. Conjugate. Okay, so now what's on the top? FOIL. What's on the bottom? FOIL again, right? FOIL again. So we have FOIL method again and again in this part. So 5 times 4, 20. 5 times I plus 5I. 4I times 4, 16I. 4I times I, so 4I squared. That's the top, okay? So bottom, we do the same thing. 4 times 4, 16. Plus 4I. And then inner product, minus 4I. And then the last one is minus I squared. Okay, minus I squared. So remember, they're all complex numbers, and this is the multiplication between complex numbers. Okay, so we have these parentheses. Okay, that's why we have distributions. We have FOIL method, right? We have FOIL method. So now let's continue. Simplify numerator and denominator a little bit. So these two on the bottom cancel, right? So we got 16 minus I squared, negative 1. On top, these two in the middle, 5 plus 16, you got 21I, right? And then we got 20 plus that, and then I squared is negative 1, so plus 4 times negative 1. So we got 20 minus 4, 16 plus 21I, denominator is 17, okay? Denominator is 17. So this is the division of complex numbers. Okay, and again, you should rewrite the answer as a complex number, a plus bi. So what's the real part? This is the real part, 16 over 17. What's the imaginary part? This is the imaginary part, 21 over 17i. Okay, over 17i. So this is not easy. Okay, this is not easy, but you should keep that in your mind. You need conjugate, complex numbers, and FOIL. Okay, and FOIL. So now I will write down another division example, and we can compare that with the radicals. Okay, conjugate radicals. Okay, so let's look at these two questions. Okay, two questions. So for the radical one, we want to rationalize denominator. Okay, yeah, and for this one, we want to find the quotient. Okay, we want to find the quotient, so it's just simply divide. Okay, simply divide. So let's do them together. Okay, they are exactly the same. Okay, they are exactly the same. So we use conjugation. So what's the conjugate of denominator? This one, radical 2 plus radical 3. So we need radical 2 minus radical 3. Top and bottom, multiplied by the same number. Okay, radical 2 minus radical 3. So for complex numbers, we use conjugate complex number. So it's 2 minus 3i. Okay, so the idea are exactly the same. Okay, exactly the same. And then we use FOIL, right? FOIL, top and bottom. Okay, top and bottom. So let's change the color. So this is F. So radical 2 times radical 2. We got 2, right? And this is, let's write down the FOIL. And then the radical 2 times negative radical 3. So minus radical 2, radical 3. Radical 5, radical 2, inner product, radical 5, radical 2. And then minus radical 5, radical 3. That's the top. The bottom, radical 2, radical 2. Minus radical 2, radical 3. Plus radical 3, radical 2. Minus radical 3, radical 3. Okay, so now let's simplify. So let's look at denominator. Okay, let's look at denominator. So they canceled because they are both radical 6. Positive radical 6 minus negative radical 6 canceled. And this is 2, this is 3. So we got 2 minus 3. Okay, so denominator is negative 1. Okay, negative 1. So numerator, this is 2, right? This is 2, the first one, minus radical 6 plus radical 10 minus radical 15. Okay? Radical 15. Okay, yeah. So the very important thing is you cannot simplify this numerator because there's no like radicals. Okay, no like radicals. So we got these 4 things on top. 2 minus radical 6 plus radical 10 minus radical 15 divided by -1. Divided by -1 just means change the sign, right? So we get -2 plus radical 6 minus radical 10 plus radical 15. Okay? So this is the conjugate radicals. Okay, conjugate radicals. So conjugate complex number, we do the same thing. Okay, we do the same thing, but you have to remember you need to change I squared to -1 in the next step. Okay, so let's keep it in the box. I squared is -1. Okay, -1. 2 times 2, 4. And then 2 times -3i minus 6i, right? Minus 6i. So this is 2 times 2. Let's rewrite it. Okay, let's write down the product. Let's write down one more step. Okay, 2 times 2 minus 2 times 3i plus 5i times 2 minus 3i times 5i. Okay, that's the numerator. Denominator, 2 times 2, f, right? 2 times -3i, so minus 2 times 3i, positive 3i times 2, and then minus 3i times 3i. Okay, times 3i. So again, the middle two canceled, just like conjugate radicals. Okay, that's why we use conjugate complex number. Okay, complex number. So we got 4 minus 9i squared. We always get a good denominator. Okay, good denominator. So numerator, this is 4 minus 6i plus 10i minus 15i squared. Okay, I squared. So again, we need this. I squared is -1, right? I squared is -1. So let's delete that, change to -1, delete that, change to -1 in the multiplication, right? So bottom, we have 4 plus 9. Top, so this is 4 plus 15, so we got 19. -6i plus 10i, so we got 4i. So this is 19 plus 4i divided by 13. We write as real part and the imaginary part. 19 over 13, that's the real part, plus 4 over 13i, imaginary part. Okay. So for complex numbers, you need distribution a lot. Okay, a lot. So now let's go back, write down all the operations of negative radicals and complex numbers. Okay, the important part of today's lecture. So if you have negative radical 2 times negative radical 8, so change this to I radical 2 and change the second one. Change the second one to I radical 8. Okay, so we have a letter I to take care of the negative radicals. Okay, that's the multiplication rule. Okay, multiplication rule. And then we have I squared radical 16. So this is -1. This is 4. So we have -4. Okay, -4. So this is the most important negative radicals. Okay, negative radicals. Right, and if we have addition, negative radical -2 plus radical -8. So this will be I radical 2 plus I radical 8. Simplify radical 8. I radical 2 plus I 2 radical 2. 8 is 2 radical 2, radical 8, right? And then we have 1 radical 2 plus 2 radical 2. So this is 3 radical 2. Okay, yeah. So now we learned complex numbers, so we should rewrite it. This is our BI, so this is 3 radical 2i. Okay. Okay, yeah, so now the complex numbers, right? The complex numbers. So we always, for addition subtraction, we always do real part and the imaginary part separately. So 1 plus 2i plus 3 plus 5i. Okay, yeah. So here is the real part 1 and 3. So we put 1 plus 3. Okay, and the imaginary part, so let's change to blue color. So this is 2, b is 2, b is 5. So this addition means 2 plus 5, b part plus b part. This is 4 plus 7. Okay, 7. And the division multiplication. Okay, division multiplication. So multiplication means FOIL, and division we need conjugate complex numbers. So let's just put a division, okay, because division has multiplication in the middle step. Okay, in the middle step. So this is 3 minus 5i, 3 minus 5i. We need to conjugate complex numbers, and then FOIL this, and then FOIL the top. You will get the answer. Okay, you will get the answer. So this is the complex numbers. Okay, it's completely new for some student. After practice, this part is not hard. Okay, this part is not hard. Okay, so that's it. That's for the 7.6 complex numbers and the square root of negative numbers.